Morning. Here's my cat. I'm gonna laugh. Anyway, it's June 9th. This is video number 9. And I've got several things to talk about today. My cat just came in. She wants to be petted right now. Anyway, I'm drinking coffee. I wanted to talk mainly about clocks and time, but if I get done with this other stuff first, I'll mention some things about that. I'm going to read a little bit from my book about LIGO. Laser interferometer kidding. Laser interferometer gravitational wave observatory. Okay. All right. And what my question starting off this morning is, where are some people that want to be naturalists like me? Okay. They're okay that they live one life, and like the other biological living organisms on Earth, when it's over, it's over. You don't go into a spirit. My physics system, there is no possibility for a spiritual realm because nothing spiritual exists. Everything is physical. Okay, that's why radio and light and every other form of radiation has mass. If it doesn't have mass, it doesn't exist. With my system, once it's adopted, religion can no longer exist, okay? We're some people that are like me that are okay that they don't live forever. We're some people like me that aren't pursuing immortality, okay? I don't care about immortality. I'm a animal. I pass along if I successfully breed, or then I pass along my genes to my children. We pass along our knowledge to our children, and things keep going in that way. What's wrong with that? Why do we have to take individuals that feel the need to live forever? Isn't that kind of like Pharaoh? Isn't that kind of like some emperor that, is trying to, why do we need that? I don't want to become a robot one day. I'm fine with being a naturalist. What's wrong with being a naturalist? When it's my time and my ticker quits or whatever, it's over. I'm fine. I'm going to try to do something that's going to last while I'm alive. Something that helps, enjoy my life too. Anyway. Okay. Religious faiths cause people to misunderstand the world. Okay. They present themselves because they're selling themselves. They're selling the services of clergymen and their advice and their explanations. They're selling that, so that they need to present themselves as something that solves problems, something that's good, a moral code. They can't say, okay, you should come to our church and tithe or give or help us build a beautiful building, or, and participate in, charities that we promote and support, or whatever, and you go through our rituals, that we believe have to do with our immortality and etc. They can't do that without saying that they're good. So they've convinced everybody that they're good, that this is how humans are good. Okay, that's baloney. Okay, they have caused more problems than they have solved problems. Okay, my mom used to always say humans need structure. Yeah, okay, so religious faith provides structure. Okay, yeah, humans do need structure, but have religious faiths really solved humanity's problems? Is it really as good as they present themselves to be? No. They have created a lot of problems. Okay? That's why we need to get rid of them. Okay? We don't need them. I'm happy not living forever. You know? I'm happy that my children hopefully will outlive me, and if they have children, and what we learn together is passed on, and things hopefully get better. Okay? That's good enough for me. I don't need immortality. Okay? I'm a naturalist. I'm a materialist. I take a materialist view of the universe to get rid of what religion did to me since I was 5 years old to 48 years old. Okay? It took up my time, took over my mind. That stuff is poison. Okay, if you take it seriously, if you're just messing around with it, playing around with it, who wants to just waste their time messing around with something? If it's true, take it seriously. Do something decisive about it. If it's false, then just let's just put it over with the other false things. Okay. Anyway, now this carries over in all kinds of concepts in science. Okay, we have all this stuff flying around, radiation that doesn't have mass. Okay, yeah, it does have mass. In the atom model that we're using is wrong, as I've already explained in a couple of these videos. I didn't really want to go there with the all of the mass is contained in the nuclei, but that's what the system presents. So you need another system. I have another system that explains it, where a lot of the mass is in the electrons and other orbiting and hovering particles that make up radio waves that get sent out. And there's a lot of these shells. I've seen these shells in large atoms that attach to cotton fibers, lensing in direct sunlight. I've seen them myself. I saw that the nucleus is way larger than why? Because those are the spherical shells that encase the nucleus. Okay? One on top of another, and they look gray when you look at them. There are other orbiting particles that are outside of those. Those make black lines. Now, the atom has to be oriented correctly. This is the way I interpret it. It has to be oriented correctly so you can see those black lines, But the other ones that aren't oriented correctly, they're blurry in the background. I've even dampened the cloth in 2011 with water. If you get too much water, you can't see anything, but if you get the right amount of water, you can watch the water molecules, and you can watch them evaporate. You don't think I have the right to come up with an atom model after witnessing that and thinking about that? Anyway, let's talk about LIGO a little bit, okay? Now, they've got two of these setups for observing. Okay, first of all, let me just make it easy for you. Gravity from other galaxies has no influence on us. I thought that too when I did symmetry and motion. I have a sheet, a print, okay, and I had to make a correction in that for this book, and I do. I made it all in red, that little section about momentum. I thought momentum was pulling, from galaxies, causing things to want to keep going. No. Anyway, I won't go into how I realized that's wrong. Motion has its own momentum alone. It doesn't need anything pulling on it. Anyway, but as far as gravity waves, which don't exist, okay, follow me now on this, because I'm going to tell you this how it really is. Let me talk about waves then before I mention this. A wave, okay, since everything has mass, is a concentration of photons, usually, or radio particles or whatever, moving out through space at the speed of light, followed by a ripple of less concentration. More concentration, less concentration, more concentration. That's a wave, okay, of particles that have mass. All right? Now, I'm trying not to sound like that again when I said all right. Sorry about that. Anyway, as far as waves, okay, another thing is the attraction of gravity is the leftover attraction from that which holds atoms and molecules together. Okay, now some photons repel. There are not little waves going out from particles, photons that repelling waves, and then over here there's some uh, um, attraction waves, and then these are ambivalent, so there's no waves. Okay, that's not. There are no waves. When you have attraction, what happens is two photons that have enough mass contrast, they move toward one another, and they either lightly attach or more strongly attach or very strongly attach. That's what's happening. That's attraction. That and the attachment that makes composite particles. Now, so this concept of the gravity would be waves too, and that light is waves. Okay, without mass. Without mass. This is a religious concept where everything's spooky, where Jesus walks through walls. That's all baloney. Anyway, okay, as far as the LEGO project, there's one setup. Let's see, these are how far apart? 1,865 miles apart. Two of these setups. They're interferometers, okay, like the Michelson-Morley setup, but much larger. They set up their mirrors, okay, and they're set up. The mirrors in this is set up, for more accurate, set up 2.5 miles apart. Now they're set up in regions where there are no, there's very little seismic activity, okay, and but the thing is, seismic activity is a problem. It's even a problem between two mirrors that are 2.5 miles apart, okay? It is. Even when you're in an area where there is little seismic activity. Here's the kicker. They're supposed to be able to sense that, okay, let's say two black holes are orbiting one another, or oscillating someplace in a galaxy, supposedly. Okay, and so that would send a real strong wave that would reach here. Okay, a gravity wave, and what it would do, it would move a proton or move some matter toward it toward it, and then it's not so much, then toward it, and then not so much. Okay, now, this is supposed to be accurate to within 1,000th the width of a proton. 1,000th the width of a proton? A proton has like 1,800 photons in it in my system, okay? I haven't figured out exactly. Well, I probably have, but I have to go back and look for that. But a proton has a diameter, okay? In my system, I did that in pixels. In my system, in the software I use, a photon is 13 pixels, okay? And that's the scale that I use. And then everything else, composite particles, they would join and make spheres, and then you could determine the diameter in pixels. Well, a proton or a nucleon, a neutron, the neutron's a little larger, it would be so many pixels of diameter as well in my system. And I'm not going to go look for that right now, but let me just say this, that 1,000th the width of a proton is less than the width of a photon. I think it is very safe to say, if protons contain 1,800 or so photons, if they're made up of these photons that are attached, okay? when you're doing a sphere, it doesn't take that many stacked on one another, making up the diameter once the sphere is filled out. When you're only talking about 1,800, that's not very many. Okay. And then you're going to claim to the world that that you're detecting something from space pulling on this when your mirrors are 2.5 miles apart, and up to the level of 1,000th the width of a proton, and you're going to tell me that within a 2.5 mile difference that seismic activity couldn't be involved? Even in the least seismic activity areas, there's some seismic activity, and you're going to say it's not going to vary in 2.5 miles, 1,000th the width of a proton, and this is the stuff that the public is swallowing and funding now. Okay, give it a try if you want to, but man, when are we going to pull the plug on something like that? All right. When humans all need to make a living, whether it's become a clergy member or, or some scientist that's wasting people's money on something that's most certainly untrue, okay? This happens. These scientists and clergy members are not above that. Living organisms, remember, by nature, we're predators. There's a lot of parasites in the earth. We have these kinds of things going on. We want what's best for us, what's easiest for us. We want to get the most bang for our buck, the most, the most for the least amount of effort. I'd like to see us all rise above that, but everything, and no, these people aren't trying to deceive. They're sincere. They're doing the best they can. But anyway, but in the background, these other less noble factors they exist. And while no one talks about them, they can still have influence. Everything is not always on the up and up. If people can live off mistakes, they'll live off mistakes. This is unfortunate. Anyway, as far as time, a clock being slowed, it can be slowed because even an atom clock, because if it's farther away from a large gravity source, because the microwave particles that are being restocked when they're sent out, that's how atom clock works, is they use microwave radiation. But that in my system, that has to be restocked, okay? And the concentration of those might be more sparse the farther you are from a gravity source. This has a lot to do with also how these particles will be restocked in the sun so they can be sent out, and why there are sunspots, why the sun's surface is variegated. Side by side, you have intake and output. If all radiation have mass, that's the way it works. Anyway, so you'd have variations in concentration of these particles that are being restocked, and that would, and from my point of view, that would cause greater intake at certain times from a certain direction, and would cause a sunspot. Anyway, as far as a clock slowing, that's all related. But a clock doesn't keep track of time. you don't know that a clock has slowed, for example, unless you have another clock. All a clock is an instrument we make and decide is consistent enough with its intervals, consistent intervals, that it's reliable. Okay, that's a clock. And a clock can fail. A clock can be off. Does that change how the passing of time, all the other processes that are rhythmic and repeating, they may not be exact, to the very minute detail accurate, but these processes go on and they're repeating all these rhythms and different things in the universe. Anyway, time is still going on if a clock fails, if a clock is off. Time is not a clock. Time and a clock is not the same thing. A clock, anyway, I'll talk about that more later. This is getting